let's work on a couple of examples. Let us do this. Let's do 8 in decimal to binary. This one should be pretty straightforward. So we have 8. We're going to subtract the largest power of 2 that is less than or equal to 8, which is 8 equals 0, and we're done. And 8 is what's important. So we have 0, 1, 2, 3. All right, that's 8, 1, 0, 0, 0. And there you have it. 1, 0, 0, 0 equals 8. To kind of show you where we got there, let's look at this table here to see how I got to this number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, that is the position of the column. And then 2, which is your base, raised to the column position, that is where these numbers come from, right? So this is your power of 2. That's going to be your 8. And once you get to 0, that's when you know you're done. So did we have a 1? Nope. So our 0 column is turned off. That's 0. Did we have a 2? Nope. So our 1 column right here is turned off. 0 means off, remember that. Did we have a 4? Nope. So column number 2, number 0, 1, 2 is off. But we did have an 8. So column number 3 is on. That's how we got 1, 0, 0, 0. Let's do another one. Let's do 59. All right, 59 base 10. Let's put it into binary. So start with 59 minus your largest power of 2, that's just less than or equal to 59, is going to be 32. That equals 27. Okay, so you gotta remember our 32. Now we bring 27 over here. And that's going to be minus 16 equals 11. 16 is going to be important. Bring our 11 over here. 11 minus 8 is going to equal 3. Bring our 3 over here. Again, 8 is important. 3 minus 2 equals 1. 2 is important. And then 1 minus 1 equals 0. And that's how we know we're done. And 1 is important. So now let's put this in a binary. So you have a 1, a 2, 8, 16, 32. So we have a 1. Yep. 1. We have a 2. Yep. On. We have a 4. No, we go from 2 to 8, so no 4. 0. But we have an 8. So we have an 8. That gets a 1. We have a 16. Yep. That's a 1. Next is 32. Yep. That's a 1. We have a 64. Nope. That would be a 0. A 128. Nope. That would be a 0. So 111011 is decimal, base 2, for the number 59. Now let's try something like this, a little bit bigger. 275 base 10. First things first. 275 minus our largest power of 2 is going to be 256. There we go. That equals 19. 256, very important. 19 comes down here, minus our next largest power of 2 is going to be 16. Should equal 3. 16 is very important. Then 3 is going to come down here. Minus 2 equals 1. 2 is important. Then 1 minus 1 equals 0. That's how we know we're done. So let's convert this into binary. All right. Remember our powers of 2's. So 2 to the 0 is 1. Yep, we have that. 1. 2 to the 1 is 2. We got that. 2 squared, I mean. 2 squared is 4. Nope. 2 cubed is 8. Nope. 2 to the 4th is 16. We got 16. The next comes 32. Nope. 64. Nope. 128? Nope. 256? Yes. And that was where we started. And there you have it. 1,000,100,11 in binary equals 275 in decimal. All right, now let's try converting decimal to binary. So let's start out with 101 base 2, and we're going to go to decimal. All right, so this is column 0, column 1, column 2. So we can start on the left. So we have 1 times 2 squared plus 0 times 2 to the 1 plus 1 times 2 to the 0. And just to reiterate where the squared, 2 to the 1, 2 to the 0 is coming from, it's the column numbers. 2 squared, 2 to the 1, and a little sloppy, but 2 to the 0. All right, 1 times 2 squared is 1 times 4 plus, well, 0 times anything is 0, so 0, plus 1 times 2 to the 0, which is 1 times 1, that's 4, plus, forget the 0, we can get rid of that. 1 times 1 is 1, 4 plus 1 is 5, and base 10. Okay, let's do another example. Let's do this one. 1, 1, 0, 0, 1, 0, 1, 0. And that is base 2, because it's decimal. All right, and we have column 0, column 1, column 2, column 3, column 4, and column 5. 0, 1, 2, 3, 4, 5. Okay. All right, this might get a little crowded, but here we go. So we have 1 times 2 to the 5th plus 1 times 2 to the 4th plus 0 times 2 cubed plus 0 times 2 squared plus, or is there 2? So 1 times 2 to the 1 plus 0 times 2 to the 0. So we can eliminate everywhere we have 0 times. Don't even have to worry about that math. So 1 times 2 to the 5th, and we know 1 times any number is that number. So we'll just go ahead and not continue with the 1. So 1 times 2 to the 5th is 2 to the 5th, which equals 32. 1 times 2 to the 4th, that's 16. There's all your zeros. We don't want those. Don't care about them. 2 to the 1 is 2 times 1. It's obviously just 2. So we should end up with 2 plus 16 plus 32, and that equals 50. Of course, that's going to be base 10, which is decimal. There you go. Good old number 50. And there you go. I hope that was very helpful. That's just some introductory binary and conversions of binary decimal to binary. I'll have some more examples later on, but my next video is going to take it a step further, and we're going to talk about hexadecimal. Thank you so much for listening. I hope you learned something. I hope you have a great day.